Welcome everyone! Today we learn how to perform SQL joins using the LINQ syntax in .NET. As a prerequisite, we'll download a simple .NET API with the entity framework configuration. So let's clone the initial branch from this repository. I'll provide the link in the description below. So open a new terminal and type git clone. Open the solution on Visual Studio. Let's take a look at the project configuration. So this is a minimal API and we have two entities. The first one is the address, which we define the ID, the street address. We have a relationship with a customer entity. So we define a foreign key, which is the customer ID, and the navigation property for the customer. This is the second entity with the ID and the name. So we have a DB context to define the DB sets for each entity. And we override this onModel_created method to set some data. So we added 3 customers and 3 addresses. In the program, we registered the DB context and we're using entity framework call in memory to simulate a connection with a SQL Server database. As you will see in the project configuration, we have this Nugget package. So that's a quick overview of the .NET API. We have this minimal endpoint, which we inject at the DB context, and we call this ensure created to create the database and to set the data from the onModel_created method. So we'll use this endpoint. Let's start with an InnerJoin. So create a new repository to define all the methods. So let's create a shop repository. By a primary constructor, I will inject the DB context and create a field to access in this class. So the first method will be to perform an InnerJoin to get the customers with the associated address. So let's create a new public. We'll return a queryable of type customer address DTO. So let's define this DTO in the solution. Add a new class. This simple DTO will return the customer name and the address. So let's call it get customers with address and create a new variable called InnerJoin to get all the matching records from the customer and the address tables. So let's start with a LINQ query syntax. So for this, we'll use the from keyword. Let's define a variable for the customer initially from context that customer, which is the DB set, to access the entity and perform a join to the address table. And then based on the customer ID for the address entity, we'll do a matching for the records. So called c.id when is equal to the customer ID from the address entity. I will just simply call the select statement to create a new customer address DTO. And then the customer will be the customer name on the customer table. So access the property and the address will be address that is street address and return the InnerJoin result. Go back to the program.cs file to define the endpoint in the minimal API. So let's go back and let me define this route for the endpoint. Will be a get action customers with address. We ensure the creation of the database and to set the data. And then we return the method response. So we'll create a new instance of the shop repository. For simplicity, we will not apply dependency injection. So let's pass the DB context and then call get customers with address method to perform the InnerJoin. Execute the API. Navigate to the endpoint URL. And as you can see, we have the customers with the address. We have all the matching records from the 2 tables. So stop the application and let's go back to the shop repository. We can use a LINQ method syntax to define this InnerJoin. So let me comment out this code and define the InnerJoin variable, but in this case with a LINQ method syntax. So for that, we'll call context.customer and we will perform a join against a second table, which will be the address. We define the out the selector, which will be the ID of the customer table, and then based on the customer ID from the address to perform a join, and we create a lambda expression which we define the customer and the address variables, and then we just simply return a new customer address DTO with these two variables with all the matching records from these two tables. So the customer will be c.name and the address will be the address variable, and select the street address. And this is the InnerJoin using the LINQ method syntax. Run the API and let's verify the results. Navigate to the endpoint and we have the same results. Both syntaxes are valid, the LINQ method syntax and LINQ query syntax to define the InnerJoin. Let's perform a LeftOuterJoin to get all the records from the customer table and the matching records from the address table. So let me copy this method and we'll return the same DTO. In this case, let's name it this as get customers. So initially define the LeftOuterJoin using the LINQ query syntax. So uncomment this code and let's change the name at LeftOuterJoin. So we start with the customer entity. From the customer entity, we'll join with the address based on the customer ID from the address table. In this case, we'll use the into keyword to get all the codes from the address table. So let's define a variable called addresses, and then we'll select an address from these addresses. But in this case, we'll define if the address, if empty, there is no associated customer to this address, will return a default value, which for reference types will be null. Then we just simply create a new customer address DTO with this select statement. The customer name will be the variable, that name, and the address in this case will be the address from all the records, and select the street address. Go to the program.cs file and create the respective endpoint. So it will be a get action with the customer's root. And let's call this method. Run the API. Navigate to the customer's root. We have all the records from the customer table and the matching records for the address. You can see if the customer has no address, it will return a default value, which in this case will be null. Stop the API. Go back to the shop repository to define this LeftOuterJoin using the LINQ method syntax. So let's comment it out in this code and uncomment the second part. Let's rename it as LeftOuterJoin. In this case, we'll call a group join method. We define the inner sequence, which will be the address. Based on the customer ID, we'll select all the records. But in this case, we'll create a new anonymous object. So we'll select the customer and all the addresses. So let's define two properties. And then we'll create a new anonymous object by passing the customer and create a new addresses property by calling addresses and default if empty as the previous LINQ query syntax to specify that if the customer has no address, we'll pass a default value, in this case will be null. And then we'll call a select many statement to get all the addresses. So we'll select the addresses. So let's create a lambda expression to get the anonymous object which contains the customer and the addresses. So let's represent it as ads and the address itself, and then we'll return a new customer address DTO. So the customer will be the anonymous object, and we navigate to the customer, which is this property, and select the name. Let me move this part in a new line, and with the anonymous object, we'll define the customer name, and the address will be this a variable, and we'll select the street address. This LINQ method syntax is a little bit complicated than the previous LINQ query syntax to create a LeftOuterJoin, but let's check the results in the API. So execute the API and navigate to the customer's endpoint, and we have the same results. So far so good. Stop the application Now let's define a RightOuterJoin to get all the addresses with the customer matching records. So LINQ doesn't support RightOuterJoin, but we can swap the tables, the customer and the address table, to perform a RightOuterJoin. We'll use the same query syntaxes, but in this case, we'll swap the tables, the entities. So let's define this method as getAddresses. Let me comment it out in this LeftOuterJoin, and let's write the LINQ query syntax for this RightOuterJoin. Rename this property. So we start from the address table. We perform a join with the customer table, and based on the customer ID from the address table and the ID from the customer table, we'll select all the customers, and we define a null value if the customer is empty, if the address has no customer associated, and we'll create a new DTO. So in this case, the customer, okay, let's change the variables. This will be an address and this will be the customer. So in this case, the customer will be this one based on all the customers. So the customer will be customer.name and the address will be the A property, that street address. Now go to the program.cs file and create a new action to get all the addresses by performing the RightOuterJoin, and call the getAddresses method. Execute the API, navigate to the addresses endpoint, and we have all the addresses from the SQL Server database. As you can see, if the address has no customer associated, we'll return a default value, which in this case will be null. So we're performing a successful RightOuterJoin. Stop the API, and similarly, we can write in the LINQ method syntax to perform a RightOuterJoin. So let's swap the tables. So we start from the address table and we perform a group join against the customer table. So this will be the address based on the customer ID from the address and the ID from the customer entity. We perform a group join. We will take the address and the customers. So we create a new anonymous object. We define the address and then we define all the customers. If the customer has no associated address, we'll return a default value. So we'll select all the customers, and in this case, this A will be represented as C, which will represent the customer instead of the address. The customer will be the C variable.name and the address will be the anonymous object. We navigate to the address and select the street address and execute the API to see the results. Navigate to the addresses endpoint and we have the same data by using the LINQ method syntax. Finally, let's write a full outer join to get all the records from the two tables. So for that, let's create a new public queryable of type customer address DTO to get the customers and addresses. So LINQ doesn't support this full outer join, but we can unite both LeftOuterJoin and RightOuterJoin to get a full outer join. So create a new variable called LeftOuterJoin and invoke the method to get the customers by performing this kind of join. And then we just simply return LeftOuterJoin and call the union method to unite both joins. So call the getAddresses method. So with the LeftOuterJoin and RightOuterJoin, we unite both data, both results to get a full outer join. So go back to the program and create an endpoint to return the customers and addresses, return all the records from the two tables and call the corresponding method. Let me copy this route, run the API and navigate to the URL. And we have all the records from the two tables, as you can see. So this customer has no address and this address has no customer. I will return in the default values, which in this case is null. So in this demo, we learned how to perform SQL joins using the LINQ syntax in .NET.